see question 5 here. So we have a function e to the power of ax divide b to the x, and we know it has a stationary point which is given. We need to find a and b. State the nature of this stationary point as well. Okay, so I've written that down. Now, obviously we're doing differential calculus and you're going to want to find the derivative, but before you do that, we can use the information we've been given. All right, so we know that this point has to lie on this function, and we can substitute those values in and see where that leads. E to the a. And there must be something I've copied down wrong, because there's no b. Sorry. On bx. Okay, I'll go back. Divide bx, that's better. Okay, so e to the power of 1/3 times a, I might just write a divide 3, and then that is divided by bx, so we know x is 1/3, so it's b divide 3. Okay, if we do a bit of tidy up, might think of this divide by b on 3 as a times by 3 on b, alright? And then we could see that e on 2 is equal to 3 e to the power of a on 3 on b. Let's keep going, do a bit of work. I think I'll cross multiply b times e. So I'm multiplying both sides by b to get rid of this fraction here. Then I'm going to multiply both sides by 2. So we'll have 2 times 3 is 6. Okay, now at this point I'm fairly sure that b is 6. And if we've got a power of 1 in here, I can write that in a different colour, because we wouldn't normally write this, but e to the power of 1 equates to e to the power of a on 3. So you could, from there you could say therefore b equals 6, and I'm looking at the coefficients, equating efficients. Yep, that's right. And therefore 1 needs to equate to a on 3 if I'm equating the powers. And so if that's true, then a must be 3 to make the 1 that we're looking for. Right. So I think that would be reasonable. It's just that the book probably wants you to find the derivative. So we will do that and see where that leads as well. It should lead to the same place. So the derivative of the function, right? And if you recall your quotient rule, if your function is u on v, then your derivative is derivative of function u times function v minus function u times derivative of function v divided by function v squared. Okay, and I think you should know that by now. so let's do that. So we have derivative of function u, that's a e to the power of ax, times function v, bx, and we have a minus. We have function u, e to the power of ax, times derivative of function v, and well, this is all divided by function v squared. Now when you're doing a question where you're using the derivative, it's always, I think, always a good idea to factorize, and I can see that the numerator can be factorized here. So I could say there's a common factor of b times e to the power of ax in the two terms in the numerator, and that would leave ax minus 1 all divided by bx squared. All right. Now I'm going to think about stationary points for this derivative because the question has prompted me to. It said that when x is 1/3 we have a stationary point, but stationary points are coming when the derivative equals 0, right? And the only way to make this derivative 0 is to look at what's in the brackets here, the ax minus 1. So we can simplify, rather than just plugging in or substituting in x is 1/3 and saying the whole thing equals 0, let's just get to the crux of the question, because we need to make the ax minus 1 equal to 0. Right? So it's like we know that this derivative will equal 0 only when what's in the brackets here equals 0, and we also know that the derivative equals 0 when x is 1/3. Right, so therefore a times 1/3 minus 1 equals 0. So we get a divided 3 equals 1. And from that, it follows that a equals 3, which is what I had over here. Right? Okay. So if a equals 3, do we have a nice expression for b somewhere? Maybe we could go back to this. Right. So we know that, what if I give this a little star or a marker? I'll call it 1. Right. Using equation 1, right, we know that b would have to equal 6 e to the power of a on 3 divided by e. Right? Okay. We want to substitute a is 3, so if we do that, we get b equals 6 times e to the power of 1 on e to the power of 1. These cancel out, equals 6, and we're done. B equals 6. All right. Yeah. Now, regarding the second part of the question, it might just be best to graph and have a look as to what kind of stationary point we have. Now, I've just got to remember A is 3 and B is 6. And then we can put this into a Desmos. Maybe if I'll just clear some space and I'll leave A's 3 and B's 6. So I know that my function is y equals e to the power of 3x on 6x. Right. So let's go and graph it. I'll open a new page. Just doing some other stuff there. Y equals e to the power of 3x all divided by 6x. And that's the stationary point there. It just said to classify, I believe. Let's check the wording of the question. State the nature of the stationary points. You could say this stationary point is a local minimum simply by graphing. You could do a sign diagram as well. But I think we've answered that question. So I'll leave it at that.